Okay, let's get to the meat of the laws of thermodynamics. Um, After we define temperature in the zeroth law, or basically what thermal equilibrium actually means, or being at the same temperature means, let's talk about the first law of thermo. The first law of thermo states that the total increase in the thermal energy of a system is equal to the sum of the work done on it and the heat added. Okay, so the total change in energy has got to equal the work done plus the heat added. Do you see how I kind of wrote a formula here just from the law itself? Total increase in energy is equal to the work plus the heat done. Now, adding energy to a system does one or both things. It increases the internal energy. And you remember, increasing the internal energy means you're increasing the temperature. Okay? Or it does work as it leaves the system. Let's see. Suppose I have a sink full of water. All right. If I add energy, if I had hot water, that might increase the total internal energy of my sink. It may increase the temperature of my sink. Now, another option is suppose I have a piston. All right. And it's sitting there and it's got a nice little cap in it that's nice and it can move. If I were to heat this up, increase the temperature, then it would push this cap up. It would do work on this cap. Now, what does this really mean? Okay, let's look at the first law of thermodynamics. Now, I have rewritten the first law just a little bit. All right, and that is delta U, or the change in internal energy, is equal to Q. And you remember Q is the heat, plus the work done on minus the work done by. Now, let me explain why I've taken the plus work and changed it. It is very confusing. Is work done on a system or is the work done by a system? If you're in the problem, you will see the work done on. I did 5 joules of heat on work on the system. Or the system does so many joules of work. So if you see the system, that's why I can't spell today. The system does 5 joules of work. That is the work done by the system. So this kind of is just a bookkeeping. Plus work on, minus work by. Now, heat can be positive or negative. If you add heat to the system, it's positive. If you lose heat, it's negative. And they are all are, of course, measured in joules. So keep your units straight. Now, let's use the first law of thermodynamics. 10 joules of energy is added to a system that does no external work. Okay, so the work is 0. Now, may I point out, all right, delta U is Q plus the work done on minus the work done by. Now, you're only going to have one of these works. It's on or by. So if I add 10 joules of energy, I'm adding heat. All right, this is my heat. So Q is 10 joules. Work is 0. So that whole unit there is 0. By what amount is the internal energy going to be raised? Internal energy is always delta U. So delta U is Q plus the work done on minus the work done by, and that is 0. So it's just 10 joules because that is the heat added. Now, if 10 joules of energy is added, now if you're adding it, that's going to be Q to a system that does 4 joules of work. So this is the work. Now, is this work on or is this work by? This has got to be work by. All right. Because it does 4 joules of external work. So it's sending it out of the system. By how much will the internal energy be raised? Well, delta U is Q plus work done on minus work done by. There's no work done on it, so it's just work by. So it's 10 minus 4, or, let's see if I got this right, 6 joules. Whoa, that's really good. 6 joules of energy. The internal energy of the system changes by 6 joules. And what it turns out is the change in internal energy correlates directly to a temperature change. We won't get into that in this class. Now, the law of conservation of energy, we've already covered. It just says energy cannot be created or destroyed, but changes form. So when you add heat to a system, it just takes that and makes it some other form of energy. It may be work or an internal energy change. Now, think about something. When I have a tube or cylinder and it's filled with a gas, all right, as the gas expands, so as it takes up more space, say I'm allowing it to expand here, um, there's less kinetic energy, so the temperature decreases. Let's do an experiment. Blow on your hand with your mouth really wide, like you're, I don't know, trying to see if your breath is bad. All right. So blow when your lips are pushed, like you're blowing out a candle, and then with it open. Which one feels cooler? Well, when you're trying to blow out candles, it feels cooler. Okay, this is an adiabatic expansion. All adiabatic means is there is no heat that has a chance to be exchanged. So this is no heat change. All right, now if there's no heat exchange, that means Q is 0. All right, so when you, by the time the air reaches your hand, it has time to expand from being compressed through your lips, so it loses energy and feels cooler. Kind of cool, huh?